So in this video we're going to be taking a look at Yankum's new offset snatch ring and comparing it to the conventional symmetric snatch rings which we all know and love. Now at this point I want to thank the supporter who sent me 2 of the Yankum offset rings which enabled me to do this test, so that's much appreciated. Now we're going to be looking at these rings in the context of recreational four-wheel driving, so not competition or professional recovery. Yankum have made 7 claims about these rings. I'm going to be examining each of them in turn and giving you what I've found and the evidence so you can make up your own mind. And at the end, I'm going to summarise and give you my own opinion of offset versus symmetrical. Now, one of the main design differences between the offset and the symmetric is that the offset shouldn't rotate when it's under load. So let's take a look at that claim. So this is what it should look like. At the top we've got a symmetrical ring which is rotating. At the bottom we've got an offset which is not. Now when I first got the Yankums I immediately put them into a double line pull with my existing dirty winch rope, and this is what happened. We'll get it to tension up. You can see that immediately it started to rotate. So let's just pull in now. So we got the car being pulled with the wheels locked. So as you can see, the offset ring is rotating, and it shouldn't be. The reason it's rotating is because my winch rope has got sufficient grip on the offset ring to be able to rotate it even though it is offset. Now if we take a look at this one, brand new soft shackle and brand new winch rope, never been used before, so we should see the offset ring behave as it is designed, which is that it should remain stationary and the rope should slip around it. If you can see here it's a little bit offset as well, it's not quite centered, that might contribute a bit to friction. So we start that up and then we can see whether or not it rotates, and you can see there is no rotation, so it's now working as designed, but clearly it needs a low friction rope to be able to work as designed. Now the offset ring can be rigged in one of 2 ways for a 2-to-1 pull, through or around. We chose to rig it through the around method for this because sometimes you can't fit your winch hook through the center and it still shouldn't rotate. However, we did check with Yankum and they say in some circumstances it may rotate. My view is that if it does rotate, because it's offset, there would be an efficiency loss because of that offset and compared to the symmetrical ring. So with either type of ring, offset or symmetric, something is going to rub as opposed to a snatch block. So which would you rather choose, the soft shackle rubbing or the winch rope? I personally would rather have my soft shackle abraded for a couple of reasons. First, the soft shackle is way cheaper than a winch rope. Second, if there is a problem with a soft shackle, I can go and change it out, etc. I can't change it so easily if it's a winch rope. Also, the winch rope is more likely to pick up abrasion as it goes over the ground and then carry that through and then start abrading your nice snatch ring here, whereas the soft shackle, it's easier to keep it clean and away from dirt, and if it gets really dirty you can just swap it out for a new one. So I would rather have the ring rotating and the soft shackle being abraded, which is the symmetrical configuration, than I would have the asymmetric where the winch rope goes around, again because I don't want to wear my winch rope out. I'd rather wear a winch shackle out. I'd rather wear a soft shackle out, and the winch rope has got a high chance of picking up debris and then rubbing it around the outside here.
Claim number 2, the rope does not fall out during winching operations.
Alright, now I'm going to do a fairly unscientific test to see what sort of effort it takes to get the winch rope out like that, which is obviously not ideal. We're going to use this original red winches snatch ring, the Yankum. We're going to rig that in a through, a factor 55, which is a very deep groove here, and also the retention, and also this ARB snatch block. So first up we'll go for the red winches, and this is just going to simulate it. So just going to show that it's, imagine that's tight at the moment, so that's all looking good, and then and yep, done it. Okay, that was the red winches, so that can be done. Now, when you are winching, if you ever get to the point where it goes so slack that everything has potentially come loose, then you need to check everything, not just whether your rope is around your ring, but also if maybe the rope is snagged on a rock, or there's a twist in extra twist in the strap, or whatever the case may be. So if it goes that slack, it's just another check. I don't really see that as being a major disadvantage. But anyway, let's delete that, and we'll now go for the factor 55, which should do better because it's got the retention points here, as well as having a very deep groove. So I'll give that a shot. Do that now with the Yankum ring. The clever thing is that we pop that through there like so, and then we take the end, like, and here's the disadvantage, so the other end goes through like that, but it's got to be an end which will actually fit through. So if you've got something on the end of your winch rope, such as a hook, it's not going to fit through, and so that's just something you've got to be aware of. Anyway, let's pull that through like so, and
so here's my rather unscientific thrash test, and you can see that, as expected, the Yankum through never ever comes out, so I just give up early with that. The around does eventually come out. Snatch block will never ever come out. The interesting one is the factor 55. It seems like their deep groove and the retention points actually really did help compared to the red winches version, which has neither of those.
There we go, got it, finally. Right. All right, fairly unscientific test, but as expected, that does prove that rigging through the Yankum means it won't fall out. How much of a problem that is in practice for you is for you to decide. Me, not a problem, because I would always put a bit of tension on my winch line, then check everything is correctly rigged, including whether or not any ropes are around pulleys, regardless of whether they're one of these or one of these or whatever. So you make your own call.
So claim 3 is the offset mass is a heat sink for redirection when the rope is passed through. Now I've got a complete video on this, but I could find no evidence to support this claim to make the offset ring any better than any of the other designs of snatch rings, all of which seem to generate some heat and more heat than snatch blocks. So watch that video for full analysis. Claim 4 is that the design of the offset ring keeps opposing lines from touching each other when you rig a multi-line pull.
So we've rigged the Yankums in the 4-to-1 configuration. So we've got the winch rope going up here. We've just got a little bit of tension on the line, not much, so there's enough to be able to see what's happening. This is now a winch extension rope. It goes around this Yankum, and then it goes around the other Yankum, back up through here, and then it goes through this Yankum, and then back down to anchor into the centre here. So one of the claims made is that the ropes don't touch. Now this is a 4-to-1, so we're just using one anchor point here, and you can see that there is separation of the ropes, but not a huge amount. That's close, but it's not actually touching, which is good. But if we come over here, you'll see that the ropes are in fact touching at this point over here, and yeah, definitely touching. Over here there is separation. So what we know to do is essentially to detension this and re-rig it, and then just sort of twist, turn things a bit here and there to get to the point where nothing's touching, which is possible, but what I found is that you can't necessarily just use the rings and then find nothing is touching. If you just look over there, just sort of down this bit, you'll see that that they're touching. Now if we turn it like that, I'm just turning it with my hand, you can see sort of turns there, so we're going to have to re-rig this. And unfortunately, I found that you can't really tell whether the ropes are touching or not until you get some tension on it, and then you put some tension on it, you can see whether it's in or out, and then you decide whether to re-rig. So we're going to re-rig now and try and get it not to touch. Oh, okay, maybe not, because it's still touching at this point over here. So it can be done, we can get rid of it. I'm sure if I just keep twisting this. Yeah, see, so it's gone, right? There's nothing there, but as soon as I let go of it, it twists over. So I need to detension it and then, I don't know, keep on turning it and twisting it until the point nothing's touching, but I've still got this knot potentially touching it. So maybe I used to use a smaller soft shackle or something else. So yeah, I think my conclusion is that you certainly can make these lines not touch with the Yankum, but it is not quite as easy as just rigging it and going. You've got to make sure it doesn't twist over somehow.
So we got the end to end, and certainly the wide and relatively great diameter of the offset ring does help if you're going to try and do this. However, I do question whether you'd actually want to do it in the first place, as I think there's better ways to rig a multi-line pull. So claim number 5 is the ring is designed to allow a cow hitch union between a winch line and a winch line extension. And me personally, not Yankum, I call this the one rope concept. So this is how it works. So if we have a 2-to-1 conventional pull, we've got our car, we've got our anchor point, we run a winch rope out, and then we've got an extension rope that goes around a snatch block or pulley and comes back. Now we can actually move the car only about as far as that green line before we need to re-rig it. Now with the one rope concept, what we have is again the same stuck car, same anchor point, but this time we can run the winch rope all the way out around the pulley, and then at that point that's when you put the cow hitch union in, and then you run your extension rope back to the car, which I've put in purple. Now that's how far you can move the car before you need to re-rig it, and that's the innovation behind one rope. It's just less re-rigging than a conventional pull. Now there is another way to do it, and this is what I call the long pull. Here's the stuck car again, here's the anchor point, and you run the winch cable out nearly to the pulley, and then you take your winch rope extension and you put that around the pulley and back to the car. Now then you can move the car very nearly as far as you can with the Yankum one rope concept, which is an advantage as well, but you then have to precisely measure out that winch length to make sure that the winch rope extension is exactly that long, whereas you don't have to in the one rope concept. Now Yankum have said that you do lose 15% of strength in that cow hitch union. I've not seen any data to prove that claim, so we'll just have to take that. You can make up your own conclusions. They said the knot must be precisely created, and it does actually minimize re-rigging and does give you flexibility. So this is how this system works. Let's say that this is the winch line, and we're going to assume that you don't have a hook on the end of it, or if you do, you have removed that, because otherwise it's not going to work. And here's your winch extension strap, and then what you want to do is join the two. Well, having removed your hook, what you can then do, and this is a Yankum 50-foot line which they sent me during the course of this video development, we pop that end through there, and in that end we've got to pull it all the way through like this. Now once that is done, then we have our union here, and then that can go around the outside of the ring, or it can actually go through the centre as well. So if I grabbed it at the end of that, we can test that theory and pull it through like this. Oops, I told you cats just get in the way everything. So yeah, that will go through like so. So that does in fact work, but again you're going to have to pull everything through and remove whatever hook you've got on the end of your winch. If you don't have one, then it makes life a bit easier to begin with.
So here's the kit list. You're going to need a winch, obviously, and a tree trunk protector, otherwise known as a tree saver. And then for the one rope or the offset version, what you'll need is obviously an offset snatch ring, and then you'll need your extension rope, and then that's it, because the amount of length you need is regulated by how much winch rope you pay out from the winch. Now, if you do it with the symmetric, then you're going to need obviously a symmetric winch ring. You're going to need that same winch extension rope. You're going to need some means of shortening the extension rope to the exact length that you need. Here I've used an X-Locks, but there are other ways to do it. So those are your pros and the cons of the two for a kit list. Now, the one rope concept does become more important for multi-part pulls like 3-to-1 or 4-to-1. We'll get into the efficiency of that in a moment. So my analysis is that yes, that claim is correct. It does offer greater winch rig flexibility, but there are other ways to do it, and there is an efficiency concern I have. We'll get onto that shortly. Claim 6, the winch is capable of multi-winch recoveries, meaning two different winches can run through the same ring. So what does that look like? Well, we're going to use one ring for two 2-to-1 pulls, which we can increase force and reduce anchor load. So I'm going to assume 4,000 kilogram winches, and this is what it looks like for a conventional setup. And we've got one car doing a 2-to-1 pull and one car doing a direct. Now that will give us, assuming 4,000 kilogram of winch power, around about 10,800, which I've calculated at a 1.7-to-1 mechanical advantage on my testing, not 2-to-1, plus a 4,000 direct pull. Now it's not exactly that because it's not pulling in a straight line, but we'll run with that for the moment. This is what the Yankum version would be. So you've got two cars, one doing an around, one doing a through pull, and that would give us 2 times 1.7 times 4,000, which gives us around about 13,600, which is roughly maybe 25% in theory extra pull, but I think it's going to be less than that once you've factored in different equations like the fact it's not a direct pull. So it's probably more like about 20%. So yes, it would work, but I think you're pretty unlikely to need this in practice, and remember the pulls will be indirect, which further reduces efficiency. So claim 7 is the ring is designed for a multi-line recovery from a single winch, increasing pulling force and reducing anchor load. Okay, so that's the sort of setup we're talking about here, but this is not unique to offset rings. This is literally what all snatch blocks and snatch rings actually do. So you can rig things like a 3-to-1 or a 4-to-1 or a 4-to-1 Spanish Burton. Now, the important point here is that with the Yankum Offset Rings, they are the least efficient that I've tested. So, for example, in a 4-to-1, the actual mechanical advantage I've measured is 2.5-to-1, whereas with the Spanish Burton, depending on the particular rings that you use and the pulleys you use, you can get 2.9 to 3.4-to-1, which is considerable. So the analysis there is yes, that is true, but it's also true of every other pulley and snatch ring, and the trade-off here is actually the one rope advantage versus efficiency. Which you're going to choose. So here's a size and weight comparison. You can see the sizes. Red winches 314 grams, factor 55, 587. The Sabre, much larger diameter, 876, and the Yankum Offset comes in at nearly a kilogram. And here's a look at relative dimensions. Remember, you often need to carry two of these, so double things. Now, there are two myths I'd like to lay to rest about the offset ring. The first is that the coating of it can be damaged. Well, it can't be. What you see there is the very first pull with a brand new rope, and the coating of the rope has rubbed off, and you can just easily remove that via a fingernail and it won't come back again because the coating's gone and there's actually no lasting damage to the offset ring. Now, the second myth is that the rope is damaged with the offset ring. It's not. Whenever you put synthetic rope through any ring, be it or pulley or snatch block or whatever else, it will tend to flatten out. And as you can see here, you can just simply put it back into its normal condition by jiggling it around like that. It is not damaged, and the offset ring is no better, no worse than any other ring or even a snatch block really in that respect. So Yankum have gone a different route with the offset, and for that I applaud them, because I really do like to see different ideas come out in the four-wheel drive industry and push thinking. However, they have made 7 claims, and overall I think I'm going to be sticking with the symmetrical ring because the advantages of the offset ring aren't enough for me to switch over from the symmetric. And the main reason is that I really like the fact that the rope can rotate with the ring so that the wear is placed on the soft shackle as opposed to the wear being placed on the rope itself. So for that reason, symmetrical rings are my choice. Your choice may be different. I've given you the evidence, you can make up your own mind. Thanks for watching this video. If you've got any questions, please drop them in the comments.